This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
The world just got a new AI power play, and you'll hear about it before anyone else writes a blog post about it. In the next few minutes we'll unpack why China's Greenlight for 20,000 Nvidia H200 GPUs could rewrite the rules of the global AI race and what that means for every developer, investor, and user who ever dreamed of a truly decentralized intelligence. First, let's talk about the hardware that sparked this headline. The Nvidia H200 is the crown jewel of the Hopper architecture, a GPU built from the ground up for the massive matrix math that fuels today's generative models. Compared with the A100 that dominated the last generation, the H200 squeezes roughly 2.5 times more tensor throughput, thanks to a wider tensor core array and a fresh NVLink topology that can stitch together dozens of cards into a single memory pool of several terabytes. Imagine a research lab that could train a 500 billion parameter multimodal model in weeks instead of months, or an online service that could generate high-resolution video frames on the fly without blowing its electricity bill. That is the kind of leap the H200 promises. For companies already running petabytes of user data and recommendation pipelines, ByteDance with its TikTok-style short-form video empire, and Tencent with the all-encompassing WeChat super app, the difference between a week-long training cycle and a 3-day sprint is not just a cost issue, it's a competitive moat. Faster training means faster rollout of new features, lower cost per token means higher margins, and the ability to keep the entire model development loop in-house means tighter control over data privacy and intellectual property. Now, why would a country that has spent years shouting, "Made in China 2025, suddenly open its doors to foreign silicon? The answer lies in a subtle but decisive shift from pure protectionism to pragmatic urgency. When the Chinese tech policy was first drafted, the goal was clear: build a domestic supply chain that could manufacture every layer of a modern chip, from the transistor to the package, without ever needing an import license. That made sense when the world's most advanced nodes were still a decade away and when the political climate rewarded self-sufficiency. Fast forward to 2024, and the reality is starkly different. The Hopper GPUs sit on a 4-nanometer process that only a handful of fabs, TSMC, Samsung, and a few specialized Chinese plants, can produce at scale. Even the most advanced Chinese foundry, SMIC, still struggles with consistent yields at the sub-5 nanometer level needed for Hopper-class designs. At the same time, the global AI race has accelerated beyond any timeline China set for itself. Companies in the United States and Europe are already deploying foundation models that can write code, synthesize images, and even design new drugs. If Chinese firms fall a generation behind, the performance gap could translate into a market share gap that is hard to recover. So the regulators made a calculated gamble: let the biggest domestic platforms import a limited batch of H200s, keep the rest of the supply chain focused on domestic development, and reap the short-term economic boost that comes from faster AI services. The move also reflects an economic calculus. ByteDance and Tencent together generate billions in ad revenue, and the incremental profit from AI-enhanced products could easily offset any political cost of bending export rules. What does this actually look like on the ground for those two tech giants? ByteDance, the creator of the algorithmic juggernaut that powers Douyin and its overseas counterpart TikTok, already runs a recommendation engine that predicts what a user will watch next with uncanny accuracy. With H200s in its data centers, ByteDance can push that engine into a new generation of multimodal understanding. Picture a user uploading a short clip, and the platform instantly generating a polished subtitle track, a background music remix, and a set of AI-crafted visual effects, all in real time. The underlying model would need to fuse video, audio, and text embeddings, something that only a GPU with massive tensor bandwidth can handle without choking on latency. For Tencent, the story is equally transformative. WeChat is not just a messaging app, it's a payments platform, a mini-program marketplace, and a gateway to countless services. By equipping its cloud division with H200 clusters, Tencent can offer developers on the WeChat mini-program ecosystem on-device language models that translate messages in milliseconds, AI assistants that draft contracts in Mandarin and English, and even game studios that run real-time AI-driven NPC behavior without sending data to foreign servers. Moreover, because the training data stays inside Tencent's own data centers, the company can comply with China's strict data localization rules while still iterating on model improvements at a pace that rivals any Western competitor. But here's the part most people get wrong. The ripple effect of this approval will be felt far beyond ByteDance and Tencent, reshaping the entire Chinese AI landscape. Think about Alibaba's cloud division, which already offers AI services built on older Nvidia hardware. If Alibaba follows suit, its customers, ranging from e-commerce merchants to logistics firms, will gain access to H200-backed instances that cut inference latency in half. That alone could trigger a wave of AI-as-a-service startups that build niche applications, such as real-time video moderation tools for livestream platforms or AI-driven financial risk models that process tick-by-tick market data. Meanwhile, Baidu, the home of the Ernie series of language models, can finally train models that rival the scale of GPT-4 without relying on foreign cloud credits. The talent pool will shift as well. Engineers who spent the past few years optimizing code for the A100 will need to master the new Hopper instruction set, the revised memory hierarchy, and the expanded NVLink mesh. Universities will update curricula, and a new generation of performance-tuned libraries will emerge from open-source communities inside China. This cascade of activity creates a feedback loop. More powerful hardware attracts more talent, which in turn builds more sophisticated software, which then justifies further hardware investment. All of this matters profoundly for decentralized inference networks like the one we're building at ChainMind. Our vision is simple: turn spare GPU capacity around the world into a marketplace where anyone can rent compute by the millisecond and get paid in tokens, while preserving data privacy through cryptographic proofs and zero-knowledge verification. The arrival of 20,000 H200 GPS in China does two things for that vision. First, it expands the pool of high-end compute nodes that can join the network, potentially driving down the cost of inference for every user. If a Chinese data center decides to allocate a fraction of its idle H200 capacity to the ChainMind protocol, developers in Europe or Africa could run large language models at a fraction of the price they would pay on a traditional cloud provider. Second, it introduces a new regulatory wrinkle. While the chips are legally imported for corporate use, the Chinese government remains wary of cross-border data flows that could expose citizen information to foreign jurisdictions. That means any node operating on H200 hardware inside China will need to enforce strict data sovereignty policies, perhaps by running inference on encrypted inputs and never exporting raw data, or by integrating on-premise compliance modules that audit every request. In practice, this could become a unique selling point for ChainMind, a decentralized network that not only offers lower costs but also guarantees that sensitive workloads stay within the legal borders required by their owners. To seize this opportunity, we're already hard-coding support for CUDA 12 and the latest Triton inference server into our node software, and we're designing token-based incentives that reward operators who can prove they are respecting data residency constraints. The goal is to turn what looks like a barrier into a market differentiator that attracts enterprises needing both performance and compliance. Looking ahead, the H200 is just the first milestone on a road that already has a Blackwell generation on the horizon, promising even higher bandwidth and dedicated AI cores. Chinese chipmakers, too, are not standing still. Huawei's Ascend line and Alibaba's Hangguang series are racing to deliver Hopper-class equivalents built on 5-nanometer processes sourced from TSMC and SMIC. Within the next year or two, we can expect a surge of multimodal foundation models trained entirely on domestic hardware, cloud providers in China, offering H200-backed instances at competitive prices, and a new wave of edge-optimized AI services that leverage 5G connectivity to bring low-latency inference to smartphones and IoT devices. At the same time, geopolitical pressure will only intensify. The United States may tighten export licenses, forcing Chinese firms to double down on homegrown silicon, while Western vendors might set up joint venture fabs in neutral territories to keep a foot in the Chinese market without violating sanctions. The net result will be a bifurcated AI hardware ecosystem, where two parallel stacks of chips, software, and talent evolve side by side. So, what should each stakeholder do right now? Chinese enterprises need to start integrating Hopper-compatible software stacks today, upgrading to CUDA 12, testing Triton, and re-architecting pipelines to exploit the new NVLink mesh. Otherwise, they'll face a painful migration later when the H200s finally arrive. Global chip vendors should explore neutral jurisdiction manufacturing partnerships to hedge against future export controls, ensuring they can keep serving Chinese customers without political fallout. And for decentralized network operators like us, the playbook is clear: build modular node software that can swap between GPU generations without breaking, embed compliance hooks that enforce jurisdiction-specific data rules, and create token economics that reward both performance and regulatory fidelity. Those who move fast will capture the first wave of cross-border AI services that combine the best of centralized scale and decentralized trust. In short, China's decision to let ByteDance and Tencent import 10,000 H200 GPS each is far more than a headline about hardware. It's a strategic inflection point that reshapes competitive dynamics, forces a rethinking of supply chain geopolitics, and opens a new frontier for decentralized inference networks. The AI future will be powered by a mosaic of silicon sources, and the platforms that can orchestrate that diversity, while keeping data safe and costs low, will define the next generation of intelligent services. If you want to stay ahead of this transformation, follow ChainMind as we build the infrastructure that turns every spare GPU into a piece of the global AI puzzle. Subscribe, join our community, and be part of the network that will power the world's most advanced models, no matter where the chips come from. The race is on, and the next breakthrough could be yours.